quarter mile away from the nearest power line, so it was like a good excuse not to connect it into the grid. I'm a NABCEP certified solar installer. You can look that one up, and basically it means I've been trained and educated on how to do this, but actually it's more of a test to show that you already know what you're doing. I've been I installed my own PV system from the beginning with very simple stuff from Radio Shack and solar panels. I actually bought out of a company that was selling seconds out of Washington, D.C. area a number of years ago. Just for fun, talk about how solar off-the-grid homes, solar-powered homes started. This is a great story. I actually met one of the people that was part of this. Everything happens in California. Well, there was all these pot growers up in the hills of Northern California, and they were making money. But they lived back up in the hills. There's no electricity up there. And so what they do is they take a car battery and they put in a car and charge it up, and then they switch them back and forth. And that got to be a pain. Or they'd run a generator, which really was loud and obnoxious. They had to buy fuel. So one of these guys said, hey, I can buy all these solar panels, and we'll just hook them up to these batteries, and they won't have to run their generators or switch them out anymore. So that's what started the solar industry. It was simply a bunch of pot growers in Northern California. But that's kind of good fun. Okay, let's push the button and see what happens. Is that the right one? Okay. The basic system is a solar PV in a load. That means a load is something that runs off the solar, something that uses electricity. This is an example right here. Yes?
What's a PV?
Photovoltaic. So, okay, that's a good question. You can speak up and ask questions. I have no problem with that. This is the solar electric panel. I could go into depth on how that works, but that's another talk. And I think we'd rather take the tour rather than have me talk about how the photons come screeching in and hit these electrons and knock them loose, and then they go to one side of the cell and they get pushed around. It's kind of it's magic, and it works. Okay, so the solar hits the cells, pushes the electrons around, makes electricity, pushes it through the wires and runs something. In this case, it'll make this little wind generator spin. There are rooftop vents that you can get for your rooftop that have a solar panel and the vent, and you can actually just cut a hole in your roof, drop them in, and it's all right there. So that's the basic solar to a load device. Usually they don't do lights that way. I'm not quite sure why, but you know, if you can figure it out, you can let me know. Yeah, right. Okay, the next type you see.
Dan?
Yes.
Can I jump in here real quick and just make a point? There are really two kinds of solar. There is solar PV, which makes sunlight into electricity, and there's solar thermal, which takes sun and heats up something.
Yes.
So you may have water panels on your house, and no matter what you do, unless lightning hits them, they're not going to make electricity for you, and vice versa.
And vice versa, correct. And two different kinds. Okay. This is the very basics of it. Solar PV, solar electric comes in, is stored in stored in something, typically a battery, and then the loads are coming out. Now that's the basic one of these that you can buy for as low as $2 a piece. Sometimes they're 4 or 6. It's the little lights that you can put in your garden that light up little patches. That's exactly what these are. They have a little solar cell on top. You've got a little battery underneath, and you've got a load, which is the little light. Now there's a little electronics in there to make it come on at night. Usually it's a couple of ways of doing that. I'm not going to get into that. But that's the basics of a system that's commonly used. The little handheld calculators, I think, use something like that. But that's the basics of it. PV, solar electric, store it, and then use it. And that's when you get into the lights, of course, because you need to store the electricity from day light to night. Okay, this works fine for little systems where you really don't care that the batteries are overcharged and nasty things happen. They last a couple, 3 years, maybe longer if you're careful with them. But that's the basics. Now, the next thing is What happens in your car if your charge controller on your car doesn't work? The alternator just sits there and overcharges the batteries and wrecks the batteries. If you've ever, and all alternators have a charge controller on it. So if you have solar panels and batteries on any size system that's bigger than a tiny one, you'll need something in there to keep the batteries from getting charged too much and being wrecked. Just like in your car, in fact, most of the smaller solar electric systems operate almost exactly like a car system and charging system. So you put in what's called a charge controller, and we got a couple up here. Here's a real basic one, and there's all sorts of different configurations. But basically, you take this thing, and it's got a place to put in your solar panels, a place to wire in your battery, and if the battery is fully charged, it just turns off the power from the solar panel to the batteries. And the neat thing about solar panels is that if you turn them off or unplug them, nothing happens. The voltage in the solar panel goes up. We'll talk a little bit about voltage a little later on. But nothing bad happens, so it just shuts it off. The power doesn't go anywhere. It actually just quits making power. But that's what a charge controller does, is prevents the battery from getting too much electricity and basically ruining the battery. And here's another charge controller. This is a fancier one. Actually, this is the one I ran my house with up until about Christmas time, or the end of the year, and then I upgraded. But this is a basic trace, and it's not even called trace anymore. I'm not sure what name would be on here, Xantrax or somebody's, but C40 charge controller. And that's a high quality, a reasonably high quality basic charge controller. And this thing can charge 12, 24, and 48, I think. This is set up for, yeah. And this is, as I say, a basic, a pretty good, little fancier charge controller. It's got a little meter on it, this particular one, so that you can see how much voltage, how is the battery up fully charged, or is it not fully charged? And that becomes important because you don't want to run your batteries until there's nothing left in them. It's just like your car. If you go into your car and you listen to the radio and you don't drive it, and you listen to the radio for a week, you're going to go and try to start that car, it's not going to start. And this is the same thing. You need something to tell you when you need to stop using the power and let the batteries charge back up. And this thing has a little digital readout just for that purpose. Here's another one, and we're going to get into this. We'll talk a little bit about this device. This is part of a kit that comes out of Harbor Freight, and it's not a high-class thing. It's kind of a low-end thing, but it does work. And this has a charge controller in it to keep the batteries from overcharging. And it's also got a meter on here to tell you if it's working. There's some other things in it which are kind of fun too. But that's the charge controller to keep the batteries from overcharging. And again, you just go to your DC loads. Well, let's talk about a little bit fancier system. This would be a typical, in fact, that's not that one right there, but it's almost this one here, except I don't think this has the right number of disconnects on it. But you have a solar electric panels, the PV panels. You have a disconnect so that if something goes wrong with the charge controller or the PV panels, you can switch it off. And this might be a disconnect that would look a little bit like this. This is actually a standard square D QO disconnect, and that has a DC direct current rating.
Can you explain a little bit more about the DC versus the AC and why? So the solar panels output the DC.
Yeah, the output of the solar panels, as I say, they push the electrons from one cell to the next to the next. Back it short. I got a little space back here.
Because in our houses it's AC, right?
Yeah, the houses are AC. DC, you got each solar cell. You'll see different solar cells, and it'll take electrons off the top and push them into the bottom of the next cell. If I were to look at this on the edge, you could see wires go like this on each cell. And there's another solar cell there. And the electrons come off the top, actually they come off the top, they go down, they go up through this next one, and then they go down through the next one. And each time the sun hits them and pushes them to the next cell. There's different layers on those solar cells that make them want to go to the top, excuse me. Tree allergies, tree pollen allergies. I think the maples are pollen. Again, a disconnect to prevent problems. Charge controller, another disconnect. Batteries. And in this case, you might use something like, on a small one, you might use a trolling motor battery, a system that we'll show in a couple minutes here. Or on a bigger system, you might need a couple golf cart batteries and so forth and so on. We'll get into voltages, but it's all DC direct current, just like in your car. But and then you have loads, DC loads, just like in the car. Your car runs off of 12 volts, the radio runs off of 12 volts, pretty much. There's a couple cars that are different voltages, but it's all 20 volts. We won't get into electric cars, they're a whole different world. But it goes into the batteries and comes out and does whatever you want to do. Same as with the car. And to get a little fancier, okay, you got your solar panels, you got a disconnect, you got your charge controller, you got another disconnect, you got batteries, you got another disconnect to your DC loads, and then you put in this last thing, because what things run in your house are mostly AC loads, alternating current, 110 volt outlets. You plug things in, 110 AC depth, and the difference between DC is direct current. That means the electrons are all flowing in one direction. And they just kind of go in a big circle. Into the battery, in this case into the battery, to the loads, and back to the battery. Well, AC current, the electrons go one way for 120th of a second, turn around and come back for 120th of a second. They're going and coming and going and coming. And the advantages with that is a guy named Tesla worked all this out. He was just a super brainiac. And he figured out that you can do lots of things with AC current. You can change the voltages with little transformers to make the voltages higher or lower, and that's what we got on telephone poles. You can run motors without brushes, do all sorts of wonderful things, and that's why we settle on the AC rather than the DC, which Thomas Edison wanted. But so that's where all that came from. So we do AC loads. So we have what's called an inverter, which there's some older technology inverters, but the new ones are all magically electronic. And I'll tell you, they're magic. There's no other way of explaining it. They're magic in there. And I've seen the people who design it, they all look like wizards out of Harry Potter. So they're all magic. So you bring electricity that's DC, magically it turns into AC and goes out and does your AC loads.
So like to plug in any normal household implement,
and
you would
depending
want
on the size, you can have a little one. Let's look at different sizes. Here's basically that right here. This actually has, let's see, what's this have on it? It's got the, this is the inverter here. It comes in here, and the AC is just plugged into this end. But here's the disconnect for the inverter. And then the battery hooks into both of these. The solar comes in this way. And let's see, what does it say? Solar to charge control. Okay, and there's one of these breakers here is before it gets to the charge controller, which is this one right here. And one of these breakers is after the charge controller. That's why there's two breakers here. That protects, this is a funny little charge controller. It works really well for a little bitty system. But that's the charge controller that keeps the battery from overcharging. And then the battery, then the solar panels are hooked up. Actually, I set it up, interestingly enough, to a piece of extension cord. It says 12 volts DC, so it's in the wrong voltage. And then ran it out to the solar panels a ways away. The reason I wired this one up this way is because last summer, just a few miles out here at the water treatment plant, you guys might know where that is. That's just out Apple Avenue, quite a ways. They had the National Model Rocket Association had their national competition out here last summer. So anybody who knows anything about model rockets probably was there. But anyway, that happened out there. And this was used along with solar panels and the battery to run their computers for the contests. So that little outfit there ran, I think it ran maybe three computers was all. But it ran computers and a printer and all the results for the
How big
national
was the
competition.
solar panel that went into there?
Actually, I'm trying to remember, I think I only had like 64 watts on it.
Okay.
4 amps, something around that. Not a whole lot. Trying to remember exactly how many I had on it, but I might have had 2, but I think I just had 1. And that's a 12-volt system there. Okay, so that's.
Why are there so many disconnects? I mean,
Why is there so many disconnects? Actually, what you want to do is, let's say something goes wrong with an AC load. You want a disconnect in there to prevent the inverter from having too much power taken from it for Friday inverter. It also protects it does protect the wire, so the wire doesn't melt, just like in your house. Okay, this disconnect on this side is just in case there's something happens to the inverter, and the battery, if you've ever shorted a battery out, you probably haven't done that, but some people probably have on a car or something, drop a wrench, you get a whole lot of amperage real quick. And if you have a disconnect with a breaker in it, it will turn it off. So that's what that one's there for. This is the same thing. If something goes wrong here, some little kid takes the scissors to a wire. You know, I had a brother who did that.
So each of those is like a circuit breaker.
It's a circuit. All these disconnects are circuit breakers, basically.
And they protect the next thing down the line then?
They protect the wire, the next thing. It's basically good safety issues. To look at that a little bit, here's the National Electric Code, big fat book. And you become, when you get NAMSUP certified, you learn everything there is about solar that's in this book, among other things, because they test you on it. It's amazing. Okay, so that's the basics of a system that, and this could grow to a very large system, and it would be basically the same. There's some add-ons like the PV panels and different types of charge controllers and things like that. But basically, this is the design of any off-grid system that's of a house type size or large cabin size.
So the photovoltaic creates the electricity. The charge controller, the disconnect protects the charge controller. Charge controller protects the battery from overloading.
Yeah, and the disconnect in there protects battery from blowing up the charge controller. And then on this end, the power comes out and goes either way to your AC loads or DC loads.
Okay.
Some houses, they don't do any DC loads. I do some DC loads and some AC loads. Depends on how you want to do it. And some of it's a little bit of a throwback. There's things changing in the industry right now. Solar panels, photovoltaic panels have gotten cheap. Not super cheap, but pretty cheap. When I bought the first ones, it wasn't the first ones, one of the earlier grouping of solar panels I bought, I paid like $4 a watt. Ooh, and I thought that was cheap. And that was almost 20 years ago. About 20 years ago. Maybe a little older. About 20 years ago. Now, you can't get them that small anymore, but the cost of solar panels right now is well under $1.50 a watt, and depending on where you can get them, if you're really sneaky, you can get them under $1 a watt, but quality may not be there, but for the big ones. So the price has come down to $1/4, yet it's 20 years later. That price, by the way, isn't going to hold. It's going to go back up again. Too many of the companies that make solar panels are going bust. So that's a little heads up. They're not going to go up a whole lot, but they'll go up some. Let's see, what button do I push? This one? Or this one? Oops. Oh, no. What one do I push to go backwards? Did I go back? Oh, what am I doing?
Oh, you got to use that little arrow there.
Yes, right.
Yeah, there you go.
Oh, there we go. I want to talk about voltages and safety issues. 12 volts is car voltage. That's what the smaller system, there's a 12 volt one over here. This panel will charge 12 volts. If you feel comfortable working on your car and putting things into it, and plugging things in, adding on something that's not supposed to be there, but you can and you feel comfortable with that, you're probably all right with working with the 12 volt system, studying up on it and working with it. 24 volts, well the 12 volts, let's say with a battery, you drop a wrench on a battery. With 24 volts, it's DC arc welder voltage. So, and there's literally people who've taken the 12 volt battery, or 24 volt battery banks and put a wire welder on it and welded things with the batteries. So, It can be done. It's still not a high enough voltage to give you a real shock. It won't. It'll kill you because something catches on fire. It'll kill you because the batteries blew apart, which I have never seen a battery blow apart, but I hear it's possible, especially if you're not charging them right. But you're not likely to be electrocuted. So based on that, 24 volts is not too bad. Yeah, if you decide to do it, that would be one size you could do. 48 volts, that's the new voltage for most larger off-grid systems that will power a house or whatever. The higher the voltage, the easier it is to, the smaller the wires are, because to get the same amount of power through, you can make smaller wires. But the trouble with 48 volts, it can kill. Barely, but it can kill. Voltages was interesting because the old railroad voltage was 32 volts. And that was set at 32 volts because this is the highest voltage that you could use and not get any sort of significant shock out of. So if you go back to the old days, they had wind generators back in the 30s and 20s, I think back in the 20s, and they had 6-volt wind generators, and that was the same voltage as the car starter voltage. And then you could get car radios and things like that. And they had 32 volt stuff, and that used the railroad lightings, lights, bulbs, and things like that. But that changed. Of course, the cars went up to 12 volts. 24 volts was kind of intermediate one, but there's a lot of there's vehicles that use 24 volts. Now 48 volts, they've stopped that. They've gone up to that point because that's the electrical code kind of froze it right there. It's a safety issue. Theoretically, anything under 50 volts isn't going to shock you, but we have a problem with that. And I'm going to the next. It's going to shock you too bad. Let's put it that way. One more. Okay, the solar panel voltage. In order to push the electricity into the battery, you need a higher voltage than the battery is. So to push electrons back into the battery to run that chemical, because batteries are just chemical storage devices. To run that, and there's a reaction that happens to make the electricity, and the reverse reaction happens to put electricity in. So you need a higher voltage to put that electricity back into the batteries. So they'll run about 18 volts, 16 to 18 volts. Sometimes it's less, sometimes more, but you better figure out 18 volts. And that gives you a good arc. And you got to be careful with it. It is the chances of burn is really what you end up with, a hot wire or something. And it's neat. It will be a hot wire. It will glow and it will do all sorts of fun things on 18 volts. There's one thing about solar panels I should say, that if you have a solar panel sitting here like this and connect the wires together with nothing else connected to it, there's only so much power that solar panel can put out, so it's not going to be a huge amount unless you have a whole lot of solar panels. It may give a little spark. It's kind of fun to see sometimes. But if you got big solar panels, it's going to be a little bit more. Okay, a little shocking, and then 24. 64 volts is what the 48 one will do. You better know what you're doing. Which means, okay, we're going to get, this is safety issues. If you're going to do 48 volt systems, go to your community college, take your basic electricity course, and do good in it. And if they got a more advanced one, take that one too. Then this is put out by the electrical unions for training electricians. It's a solar photovoltaic book. It's pretty good, but you've got to have some basic electricity knowledge and wiring knowledge to get into that. So if you want to get into the higher voltages, get some training or find an electrician. Most electricians know AC power, like in your house, but not a whole lot of them know the DC power. So you have to look around and see who you can find that's willing to work with higher voltage. Now, what's 120 volts? Why would there be 120 volts? The batteries only go up to 48. Excuse me again.
My son's getting those.
Caffeine, man. Well, there's another type of charge controller. That's called a maximum power point charge controller. And it's magic too. And again, it's the same people who do the inverters. Those guys are the same people who come up with the maximum power point charge controller. they can magically take 120 volts or somewhere in that range. Typically, in my case, when it's about 100 volts on my system, 90 to 100 volts, it magically turns it into 20. My home system is 24 volts because I started out not knowing a whole lot, so I was keeping it safe, keeping it in this range. But this new charge control I got takes about 100 volts, 90 to 100 volts, and magically turns it into 24 volts. But at the same time, it magically makes the amperage higher, which is, in electricity, there's volts and there's amps. Volts is push, amps is like, it's a garden hose. That's the best way, it's a garden hose. In a garden hose, you've got pressure coming out, and you've got flow. Flow is amps, pressure is how hard it comes out as volts. So that's the same thing. So typically on the regular charge controllers, it just opens and closes the valve and lets it out. You know, either lets more amps out or less amps out. With the maximum power point charge controllers, they magically turn that pressure into more gallons per minute. As I say, it's magic. But that means you're working with panels that are connected at a higher voltage. In fact, we connect 3 of the standard panels together. And we'll see standard panels in a few minutes. And as I say, get an expert, get somebody who knows what they're doing on that. Okay, there are systems that are off-grid that use different types of inverters and different types of systems. And 480 maxing out potentially at 600 volts, but they're never 600 volts. But 480 volts would be a common voltage on those. There's only a few people in the state that have been trained enough to actually know what they're doing with them. As I say, call me, you know. I'll tell you if it's above you or not. It's probably above you anyway. I barely got it, but 480 volts DC. It's a string of 12 solar panels, one after another. Each one's putting out 30 volts. So it's the nominal is 360. But then when you disconnect it, the voltage goes way up, and you can get 480 volts or something like that. There's some variabilities there, but somewhere in the 480 volt range. And it's really neat. I have a way of keeping people from bothering me. Don't try this at home. When I got them up, and after I've checked the voltage, make sure I got it hooked up right. I got the 2 ends of the wires there. And I have about that much wire on the end of each one, so my hands are way far away. And I always make sure I got my safety glasses on and stuff. And I have the guy stand about 15 feet, 10 feet away at least, touch them together and make this beautiful arc. Because it's going to put out, each solar panel is going to put out about 8 amps at 480 volts. So as you pull it apart, it gets quite long, and it melts the ends of the wires. They don't bother me after that. It's really neat. They say, okay, go ahead, you do what you need to do. We'll be over here someplace. And when I tell them, do not touch something, do not hook something up, they listen a lot better after that. And I still have to watch them, but that's how much voltage you can. The trouble with the DC voltage like that is AC voltage turns off every cycle. It goes one way, and turns around and goes back. It's off, and therefore there's a potential for dropping it. DC voltage is continuous, so if it grabs you, your muscles tighten up and they won't let go. So be very, very, very careful, especially with the higher voltages. Let the experts handle that.
So I wonder if you could go through the things, some of the towards the end.
Yeah.
I wonder if you could go through some of these different voltages and the setups that you made graphs for.
Okay.
And explain maybe what those can do. Like what can those power?
Okay.
And how can those be used? So for example, if somebody wanted to do like a fountain or something.
Well, let's go back to this. We'll look at this right now. 12 volts, you can go as big as, you can run a small cabin easily with that. There's people who have been doing that for years. It just means the wires are big, and the wires cost money. The real big systems are going to be higher voltage. That will be ones you put in a house with. The rooftop fans, if you're running a fan or something, there's a lot of 12-volt fans. Right now, I'm running an electronic box fan through a box I made up with a fan on it, and then there's a filter behind it. And hopefully it's filtering out. It doesn't seem to be working that well, but it usually filters out most of the pollen, and I can sleep better. And that runs on 12 volts because the 12-volt electronic box fans are available at Radio Shack. Also, a 12-volt system will run your recreational vehicle stuff. There are toasters and blenders and water little things. Anything that plugs into your cigarette lighter will run off a 12-volt system. You can charge your cell phones real easy with off-the-shelf things. But that's what's really nice about a little 12-volt system. An example of that is this one, I've got a sheet up here, you can pull the ideas off of. But this is Harbor Freight. There's a sheet, you can come up and pull the name. They're on the internet. I don't know if there's a Harbor Freight around here. There's one down by Kalamazoo. They sell a kit that has like 3 panels in it. They're only 15 watts each. They're pretty small. But they have this little kit here, which has plug-ins for everything, so it just plugs in. They even have a 12-volt light that comes, a couple of 12-volt lights and outlets. So you can basically get this thing, and all you need is a 12-volt battery. It's really kind of neat. Here's the solar panel. No, that's not solar. These plug into the front. These are the lights. And it's got a little digital readout on it and a cigarette lighter. It's not particularly well made. There's just another 5-volt USB plug on it, and a 3, and a 6, and a 9, and then the light for low voltage. So it's kind of neat.
That's not an inverter though, right?
It's not an inverter, it's all DC, all direct current. So this is kind of your control panel. Think of it as a control panel. And the price they have listed here is $189. And I think the life expectancy of these panels, they're made a little differently than most. It's depositing the layers on a piece of glass. How long will it last? If it lasts 5 years, you've got a good use of it. It's good enough to learn from. If you wanted to play and learn, it's great for that. It'll put out enough power, as I say, to run a few lights. You might run a radio. You can put a small inverter on it. Depends on how much you want to use it. You can easily run down the battery by doing much with it, but it's kind of a fun little kit. As I say, 3 of these panels, and they got a little rack with it that's kind of wimpy, but it's kind of like, oh, this is kind of fun. I got one just because it was kind of fun, and it wasn't too horribly expensive. So for, a little under $200, plus, with tax it's up to about $200, plus a golf cart, not a golf cart battery, but a trolling motor battery, you're up to around $300, and you can play. So, and that's, a trolling motor battery can handle about 100 watts or about twice that much power. After that, you're getting into using what's called golf cart batteries. Electric golf carts have batteries that are about that big and weigh a lot. And that would be, for more than twice this. So you're kind of building it up.
What would that be used for? What sort of appliances would one use a golf cart battery for?
Okay, if you jump up to golf cart batteries, 2 golf cart batteries, you could run a nice little cabin back in the woods. You could light. Refrigeration is a bit of you're right on the edge. There are some refrigerators, there are specialty refrigerators that will kind of work on 100 watts of photovoltaic and a couple of golf cart batteries. The golf cart batteries are 6 volt, by the way.
Oh, okay.
Okay, so 2 batteries connected end to end, and you've got 12 volts. So a couple of golf cart batteries, and away you go. Some specialty DC refrigerators that could be used. You have to get the smallest one. It will run you lights. You can put a small inverter on it like that one or something like it, and run a few AC things, but you're kind of limited. You put a couple 100 watts of solar panels. We'll see some panels out there that are almost 200 watts each. The typical solar panel we'll see in a minute is about 250 watts. So you're kind of in the next step up when you get to 250 watts, and that's about as much as you want to put in a couple trolling motor batteries. Okay, so you're in your cabin. One of the things you can do with this is you can run a room for fun. or you can run all your charging or something like that. You get to the next size up, and you can run the cabin out back and have your lights and, well, maybe not big screen TV, but that's a whole nother talk on that, and we'll get into where you can hear that talk on energy efficient appliances, but that's in a different place, unless they have room in the one up in Michigan for the talk I'm going to give in Wisconsin. 24 volts is the next size up. That will nicely run a cabin. The problem is there aren't a whole lot of 24 volt items that you can run directly off the batteries. There's a well pump, a couple different kinds of well pumps that you can run off of 24 volts. And there's some, the refrigerators, most of the refrigerators that run off of 12 that are the more efficient ones will also run off of 24 volts.
So if one wants to like run a fan,
yep,
or a pump or something like that, they would need to make sure that it runs off of 12 volts. The pump that they run.
Unless you're going to go to an inverter, but then when you're running, I would typically if you're 12 volts, you might have an inverter for doing a little bit, but you're not going to. When you say a pump,
like a water pump, like a small water pump for like a fountain for a fountain.
Well pump or
like a little fountain pump.
A little fountain pump. Usually those often are 12 volts, and they'll run nicely off of a little 12 volt system.
Okay.
What about a well pump?
A well pumps, there's different kinds of them, but the typical well pump is 240 volts, and that AC, and usually they run, depending on the size, there's big ones and little ones, they can run 5 amps to 10 amps, which is a lot of power, and requires one of the bigger systems into the 24 volt to the 48 volt type systems. So you're talking, in a house type situation, they're big. Now there are 110 volt well pumps that we've had people put in. In fact, the one house that we're going to be looking at in a minute, I'll show you. That's exactly what he did. There's another well pump that can run on 48 volts DC. It's an AC well pump, at least that's what it's called, but it will run off of DC, and that's a little sneaky. But it'll run off of 48 volts, so it'd be a bigger system. But well pumps, you're definitely getting into the 24 volts, except there are some specialty well pumps that only pump a couple gallons a minute, 1 or 2 gallons a minute, that can be run off of the 12 or 24 volts.
That's what they use out west, where they don't need water all the time. They use these small intermittent pumps that run DC, like to put water in the water tanks for cattle or horses or something. Because they don't have to run, whatever you need, and
they run just, in fact, they're very much like this fan here, with a little bit of extra electronics in it. But the sun comes out and pumps water and pumps it into a tank. There's different theories on that now. I pump my water with a 24 volt DC pump. It only pumps between 1 and 2 gallons a minute, which is a little bit obnoxious. But I don't have to run it through my inverter, which is really not big enough to run a regular well pump. And that reduces the draw on it, which means I can use my inverter for other things and not worry about pumping water. But that's another subject. Excuse me. The 48 volts, that gets into your regular housing, and you can grow those systems to be very, very large. 48 volt batteries, nominal batteries, they can get really big. There's mansions out west where people wanted to be grid tied with battery backup or just off grid, and they'll have system. Well, we'll see in a minute. I'll show you in a minute. And they'll live like a normal house. Typically, in the off grid situation, you're going to want to use less energy because the systems are expensive. What's happening though is the solar panels have gotten cheap, so it gets easier. But the problem is the batteries haven't gotten cheaper, so that becomes another problem. Well, let's go on a little bit. Okay, a little bit of history. Anybody recognize what that is? You've probably seen it out there. They used to have little gas engines on, little diesel engines on. And a number of years ago, I watched them change to almost all solar in about 3 years. So on my first one, within 3 years, they'd all changed. There's a battery box in the bottom and a solar panel on the top. And they don't have to, see the key was they'd have to go out there every day and make sure the fuel tank was full fill up the fuel tank a little bit, make sure everything was working, make sure that there was oil in the engine and everything was doing what it's supposed to. And they didn't do that, and that costs a lot of money. They did this with solar. They changed the lights out to LEDs to use less energy. So the way you could tell by looking at them is that if they kind of glowed on and glowed off, they were the old light bulbs, but if they came on instantly and went off instantly, they were the new LEDs. And you could tell from a long ways off that they were solar when that transition was coming through. They efficientized the lights, and actually that's a very nice little off-grid system. So when the zombies attack, and you want a nice solar system to keep your little hideaway, you know, you're up in the mountains where you can guard against zombies. You just hook one of these up to the back of your car and go. But it has to be a zombie attack. It can't be anything else. Okay, this is a little trailer that we use. This has got a 235 watt panel, but the same panel is now 250 watts. That's the growing up in efficiency. And inside that trailer, which you can only see the box of, is an inverter, the right number of disconnects, and two 12-volt deep cycle lead acid sealed batteries. And we can take this out to a job site and use drills and saws and everything else and build solar panels. In this case, we're charging Chevy Volt. So, you know, that's just for fun. And it's not my Chevy Volt. We borrow it from the dealer. He lets us borrow it anytime we want to show off his car. I don't know why he lets us do that. Turns out that one solar panel, the newer version anyway, will run a Chevy Volt about 1,000 miles a year. And not necessarily put into a battery system like this, but typically gone and put into what's called a grid tie without batteries, where the power literally goes from the solar panels to that inverter we showed, no battery, right to the inverter and right to the power company, right into the power. Okay. Let's see what's next. Oh, okay. This is it's a grid tied with battery backup, but the only difference between this, on some weekends it's an off-grid system. It's very easy to make a grid tied with battery backup, an off-grid system. You just flip the main breaker on the house, and all of a sudden you're off-grid. It's really neat. In fact, I can make any of your houses off-grid. Just go flip the main breaker. Now you're not having electricity, but you're going to be off-grid. So this is solar panels. These are a little bit smaller. I can't remember what the wattage is, about 240 watts or so. Each panel, there's 12 panels here. This is designed to tilt vertical in the wintertime. There are some systems in this area. There's 4 systems in this area. One is actually the closest one to see. What's the name of the road down there with the Brown Brothers?
Oh, Lake Harbor.
They have a 10-panel system.
Lake Harbor Road.
Yeah, down there by the state park on the south side of town.
Mm-hmm.
Yeah, just north of a mile or so north of the entrance to the state park.
It's where Garfield comes into, and I can't remember the road it comes into.
Lake Harbor Road?
If you get out of Petaluma and come up and make that curve north, you go by it. But anyway, and that's designed to go vertically in the wintertime to shed the snow and also get snow bounce, and it really works well.
If anybody wants to talk to them about that system, they love people stop talking to them.
Oh yeah, we had more fun with those guys. It's almost like every so often I have to swing by there just.
Plus they have eggs and chickens.
Yeah, eggs and chickens. Yeah.
They'll actually give you a tour. I've been there, and they'll show you their whole system. And
yeah, they're a grid tie without batteries, so they have no batteries. But that's fine. They're also feeding the power back into the power company, all of it, and getting paid 26 cents.
I think they're 26 cents a kilowatt hour.
Or here under that, regular 26.
You pay consumers energy probably 10 or 12 cents a kilowatt
12
hour.
cents.
But they get paid 26 cents a kilowatt hour.
So and they were producing more than 50% of their power on an annual basis. Yeah. So throughout the year, on average, they gain.
Yeah, they made money.
They're making money every year off the thing. And there's 2 panels less than that. So, okay, this is the inside of that, inside from those outside panels. The big white box is batteries. This is a system that would be nice for a house that you're living in about the 1950s, late 50s, as far as electrical use. That's a 3,500 watt inverter, and I'll point out what different things. But the battery bank has 8 what are called L16 batteries, and if you've ever seen golf cart batteries, they're about like this, about this tall. The L16s are about that tall, and they weigh close to 200 pounds, and they are a pain to put. Actually, not. They feel like 200. Okay, but there's the batteries that's hooked into the inverter. Now I'm going to point at different things. Okay, the solar comes in from outside, goes through a disconnect. There's disconnects down here. The DC disconnects are down here. The AC disconnects are up above. Comes in here, goes through a disconnect on the far side, goes into the charge controller. This keeps the batteries from overcharging, comes out of here. And then this hooks into and it'll either go in the batteries or go into the inverter. It's got different lights on. This turns the DC electricity into AC electricity. Comes out the top, goes out that, goes to a disconnect. Again, that's more disconnects for the alternating current, the household current, and then it goes over to the house from there. And it runs the well pump. We can run the well pump. We put a 110 volt well pump in there, so it runs the well pump directly, because this only puts out 110 volts. It runs the refrigerator, fuel lights in the house, the electronic ignition on the gas stove, a few other things in the house. But so they become off grid by flipping the main in the house, and not all the lights come on then, but most of them do. This one's kind of nice because these are all connected together through that little box up there, and this is a readout that tells what's going on. And those lights, those green lights up above, tell that it's basically fully charged, and then there's other lights that tell different things that are going on. It's always very important with the fancier systems to know what's going on. How much does this cost? Well, at the time, it was right around 25 grand. I think it's a little bit less now. The inverters didn't go up in price. The batteries stayed about the same, maybe went up a little bit, but the solar panels went down. So we're talking someplace between 20 and 25,000. A lot of money, but the reason this guy put it in is he was going off to Afghanistan as a reservist, and he had cattle. And he had a way of hooking up a generator to water the cattle that was, I consider it life-threatening. And he had a son that was 18 years old, and he decided he wasn't going to threaten the life of his son to try to hook this thing up. So he had us come in and put this in. What this also does is this feeds power back into the power lines when the batteries are full and when it's being off-grid. So it's kind of a dual purpose. But that takes a very special inverter to feed back into the power lines. I don't know what the next slide is. Okay. Well, in an off-grid system, if you were going to run a whole house like I do or other people, wind generators can be awfully handy because we have this month called December, and December sucks. It's just perfectly horrible. And so a little extra wind helps. This is in a house, I believe. I'm not sure if this one is in a house or if this one is just a demo. They all look the same. But that's a 1 kilowatt, 1,000 watt wind generator. Now, talk about wind generators for half a minute. Wind generators are not the best cost solution in an off-grid system for most of your power. Photovoltaic is so cheap now, wind won't touch it. But it's a nice addition. For on-grid, don't bother unless you really want it. And if you want it, because it's like think of it as a basketball. You don't need a basketball, but you want it real bad. Yeah, that's a nice little 1 kilowatt wind generator. It's made it comes out of a company in Oklahoma. Okay, this is the system that wind generator went in. This is old equipment. Actually, these are the inverters here. Again, disconnects for the AC over there. The wind comes in here. This is the controller for the wind generator. And this...
the charge controller?
Hmm?
The charge controller?
There's a charge controller for the wind generator. Here's the charge controller. She's got solar photovoltaic on it. And this feeds power back in the grid also. This is good time battery backup. But if you turn off, there's a way you can turn it off and turn the house off grid. And there's the battery box down over here. And there's metering for the wind generator there, and lightning arresters there, and all sorts of good stuff on it. There's the solar coming in right there. Lots of room for addition. And this is the disconnect for the inverters off the battery. Goes over there. Pretty cool. Pretty, two inverters hooked together, so they're both 110 volt inverters, and they work together to make 240 volts because they're plugged together with a special cable. That doesn't have to be done anymore. There's 240 volt inverters, the bigger ones for bigger systems. And again, you're talking costs on these things. You can get anything you want if your checkbook's big enough. But if you want to play around, as I say, these little 3-panel jobs are a lot of fun. Okay, this is the last picture I have on here, but this is a battery bank. This is actually, we're talking battery backup, but this is a battery bank. These are, what, am I looking down at them and got the picture sideways? No. These are, batteries are laying on their sides. They're glass mat batteries. They're not flooded, so they can lay on their side. And each one of those little boxes is one cell. And a cell is like your little flashlight battery is one cell. And these are big flash. These are big honking batteries, and each one puts out 2 volts. So you can start. This is just before. Well, you can't really tell on this because I don't have them wired up yet. But they were all connected together by the time I left there and hooked up to the inverters. This is one of those systems that the batteries are 48 volt, but the solar panels are the 148 volt or the 136 volt range. So they come in at different voltages, and they do. The inverters again are magic. Actually, those inverters were designed over in Europe, and they're really nice, but they're pricey. It's a pricey way to do it. He had more money than I do, that's for sure. Okay, at this point, let's see if I got, it's about right. Okay, any questions or anything you'd like to know? We're going to tour in a few minutes.
You said that you can go directly into the grid?
Yes.
For solar, and that might be something I might be interested in, because I don't care to store it.
Yeah, and turns out that's a lot cheaper. You can go that one I showed with one rack of solar panels, and it goes into batteries and all that. Turns out that you can have 2 racks of solar panels and not go into batteries for about the same price.
Plus, your solar panels will last about 25 years, and your battery packs will last between 5 and 10 if you are really.
Yeah, it depends on the batteries.
Yeah, but they're not huge. I mean, in other words, they're not going to last as long as solar panels, so they're going to have to be replaced at least once.
Yeah, I have not known. There's all sorts of different batteries when you get into a system like that. We don't recommend spending a huge amount on your first battery bank because you're going to ruin it. You're just going to ruin it. I've gone through multiple battery packs. I know exactly what not to do anymore. A lot of people will put 2 strings of batteries or 3 strings of batteries, little batteries, and puts a string. Okay, that's cool. You got a battery, and you got a battery. A single string of battery, let's put 4 of them. You wire them one to the next, to the next, to the next, and you run these 2 wires into whatever you're going to run with them. That works out best. You're better off getting bigger batteries and having 1 string rather than using the same small golf cart batteries and having 2 strings. Those L16s I talked about twice the size of golf. Because if you do this, then you connect this one up here, and you come off here and connect this one down here. What happens is that sometime this bank of batteries, one of these banks is going to start discharging into the other bank. It's going to start sending power back into the other bank as they get older, and that just is a waste of energy. And so if you have a single string, I found that a single string of batteries of the same, it will last longer than 2 strings of the same batteries. It's weird, but that's what worked out with my thing, even though you didn't have quite as much capacity. But basically, you want the biggest single string of batteries you can get.
Dan, why don't you touch on, because you talked a lot about volts.
Okay.
But why don't you touch on the balance between volts and currents or amps, and how they have to look at that too.
Okay. As far as sizing, okay. Let's say 12 volts, okay.
I mean, I wouldn't get real complicated, but just.
Could we also, would it possibly also to frame it in terms of like, what type of appliance we're talking about? So let's say we're...
Okay, let's,
Full hard.
Let's say I want to...
Okay.
Like I said.
Let's say you have a 12 volt, we'll compare to 12 volts, and we'll go extreme, we'll go to 24 volts, 48 volts. That's not extreme, 48 volts. 48 volts, okay. Now, we'll run a couple of things. We're gonna start with
something small.
let's see, a 50 watt. Well, these are 5 watts. Oh, by the way, you can get DC compact fluorescents from Menards.
Which means you don't need an inverter, right?
Yeah, which means you can run them right off the batteries.
Awesome.
They're about $9 each. So I also got some other fun things too. They have lots of LEDs that run off of 12 volts. It's got a little form. Okay, let's say we're going to put all our lights on and we're going to have 24 watts, which would be 6 of those light bulbs, 24 watts. It says right on there watts. So I have 6 lights. 6 lights.
You need those.
No, that would be 8 lights. I got 8 lights. So I'm lighting 8 watt lights. Okay. And we're going to put the same down here. 24 watts. What's a watt? 1 watt equals 1 volt times 1 amp. But basically that's the equation. If you have a higher voltage, if you have 12 volts here, yeah, it would be times what would that be? About 0.08 amps. Yeah, that's about 0.08 amps. So based on that, if you look at 24 volts at that many watts, that equals about 2 amps.
Here's a better marker for you. That much.
That's probably all I had. So 2 amps. Well, what does that mean? Well, that's a wire size issue. The 2 amps is not a big deal. You can run that through just about anything. Okay, 24. You divide 24 by 48, and you get, oh, ain't that pretty? No, that's fluorescent.
Told you we were high class, Joey.
0.5 amps. And what does an outlet in the house? Those are like 15 or 20 amp outlets. So that's how much you can run through an outlet. So 2 amps is not very much. It isn't going to mean you have to have very good wire. Okay. So let's change that. Let's run a well pump. Let's see a well pump at. Let's see. I'm going to have to do a nice even number. We got a big well pump. We're going to put 1,200 watts. 1,200.
The appliances say.
Oh, this is a big thing. It might be a toaster oven. It might be something fairly big. That's really too big. I don't want that big.
But the
1,000 watt microwave.
Yeah, let's say, yeah, okay. I'll do 1,200. That's a microwave. Okay, we're going to kick out our microwave.
And when you buy the appliance, it just says on the side.
Yeah, it says on the side what it is.
What you need.
They're not always accurate, but they're usually not too far off. 12, this equals then 100 amps. So if you'd have to have an inverter for this one. But 100 amps, you know how big wire has, in your house, you have service coming into your house, it's either 100 or 200 amp. That big wire coming down into that, it's about the size of my middle finger there. I'll do it this way, that might be better. So that's the type of wire. Now we do it with 48 volts. We divide that by 4 and we got 25 amps. So you're looking at a lot smaller wire. And because there's another thing that goes on, I'm not going to get too deep into this. the voltage drop when the wire heats up, electricity goes through it. It doesn't all make it through. Some of it's kind of slowed down, and you get what's called a voltage drop. So you may start out at 12 volts at the battery, but by the time you get to something, it might be 8 or 10 or 12. It might be 10 volts. And if you have that many amps, it's not good. So you need really big wire here. You know, maybe as big as my finger there, right there. And for the other wire, you know, something more in the range of this right here would be fine. And so it's a lot cheaper on the wire. And that's one reason to go, and there's some other concerns too, that's one reason to go to a higher voltage system. And if you look at that type of thing, that's a big item. And so that means that, okay, the wire can be smaller there. And remember we had the batteries. We have a long string of batteries here. There's your 12 volt. Think about how big these wires have to be coming off the battery. But if you're only talking 25 amps, all of a sudden, all these wires, and we need to keep going here. We need more batteries, so that's all right. And we're going to come off of this one, and go like that, like that, like that, like that. But these wires can be much smaller than they need for that 12 volt system. So if you're only doing a few little things, yeah. Once you start getting a bigger system, then you want to do more, then you go with the bigger voltages. And why do we stop at 48 volts? That's code. And they say basically, any bigger than that, you have to do some real special things with the batteries to make sure that no one gets blown apart with the battery voltage. Because as you know with a battery, if you touch the ends of the terminals, there's nothing to disconnect. So what they end up doing, there's a way of doing it, they put a disconnect in the middle there. And they do it in banks. But that's not done in a residential area. That's done typically in a situation where it might be a remote antenna type of thing, or a remote transmitter. That you might be a cell phone transmitter or something that will go on higher than 48 volts. But for residential, 48's the limit.
Do you guys think, it's up to you guys, but I have some worksheets that kind of lay out how you can kind of size so that you can figure out if you want to buy a little system. You can kind of size it out with your stuff you want to put on it and see if it works or not. Should I print some of those out, you think?
Yeah, that'd be great.
Yeah, great.